I think we're ready now to learn how to do operations on block diagrams in order to simplify them. But before that, let me tell you that most control books include a table of block operations. You can have a look at them, but I don't recommend you to learn them by heart. Just as I don't recommend you to learn the results in this video by heart. As you'll see, the operations are pretty straightforward, and when you face a block diagram, you almost always know what to do, even if you don't know what particular operation you're applying. And in fact, if you try to solve diagrams by finding similarities with the tables, by using tables, you're, in my opinion, more likely to get mixed up. So leave aside the tables and use only the golden rule of block algebra, so to speak, which is that you should have the same after the operation. You should have the same outputs and inputs that as you had before. For example, let's go over some simple systems. Here in the first one, we have an input, which is x, a block, which is g of s, and the output y1, which is equal to gx. And there's also a takeoff point in which we take the signal and carry it somewhere else. Obviously, y2 is equal to x. What kind of operation can we do here? Well, we can take the takeoff point beyond the system. How can we do that? Well, the relations should be the same, as I said. So here we must have x, and here we must have y1 equal to gx. Therefore this should be g. But if we don't want the takeoff point here, we want it here. But if we leave it this way, then y2 would be equal to gx, and that's not what we had before. So we need some space here, and we have to multiply this by 1 over g, so that y2 becomes or is equal to gx 1 over g, and then they cancel out, and we have the equivalent system, or the system after the block operation. If we want to do the opposite, if we want to bring it before the system, if we want to bring the takeoff point before the block, what can we do? Well, again, this is equal to gx, and y2 is equal to gx2 too. So maybe we can do this. This is x, and this is y. This is y1, which is equal to gx. So far everything is alright. But if we put the takeoff point here and we do nothing, the y2 would be equal to x, and we don't want that. So we need to copy here. Well, maybe copy is not the word. We need to put here the same system, the same g, so that y2 is equal to x times g, or maybe you prefer g times x. And again, here you have another block operation, which is in the tables, and we can continue doing that on and on. Let's I don't want this to be too long, so let me use the pause button. There we go. Here we wanted to move the summing point beyond the system, well, our y was equal to g times x1 plus g times x2. So we can if we move the summing point after the system, we need to multiply the signal by g, so that here we get gx1 plus gx2, just as we had before. In the next operation, we want to move the summing point before the block. And this is what we get. If here y was equal to gx1 plus x2, well, here y is equal to gx1, but since now we are adding the signal before g, we must divide x2 by g, so that 1 over g cancels out with g, and in the end we get gx1 plus x2. Well, those are maybe the four more complicated. This is simply two systems in parallel. Well, there's no trick here. The output, I don't know why this is x. This should be y, and this should be x. So y is equal to g1 plus g2 times x, and well, we can use block diagrams, but it is a I don't know, very straightforward operation. Here is another very important one, a feedback loop. In a feedback loop, the input is x, the output is y, and maybe this is the only one that tends to be remembered by heart, although I don't like that either. So let's calculate the formula. Here, as you see, y is equal to g times what we have here. And what do we have here? Well, we have x plus, since there's no sign here, we assume that the signals are added. So x minus h times y. So we can rearrange this as gx, well, expand it. Gx, sorry, this was plus gx plus ghy, and now we can rearrange it. Y times 1 minus gh is equal to gx, and finally y is equal to j over 1 minus ghx, and this is the formula. So you can put this in a block if you want, in a block whose input would be x and whose output would be y. But most commonly here we would have a negative sign, because what we feedback is subtracted from the reference or the input to the system. So the only difference then is that here we have a negative sign, a plus here, and a plus here. And the formula, although I wouldn't like you to learn it by heart, but if you want to remember it, it's just the forward path in the numerator divided by 1 plus the forward path times the feedback path. This is the formula of a feedback loop. Finally, if we have two systems in series, obviously it can be replaced by the multiplication of both of them. Very easy. And commutativity. if you have summing points to a signal, you can switch them, because y would be the same. Y would be x1 plus x2 plus x3, despite the fact that you are adding first x3 and then x2. You get the same y, so you can switch them, just as happens with takeoff points. As you can see, you have the same signal in all the points, because it is actually the same signal. A takeoff point doesn't modify the signal at all, so this is the same as first taking it this way and then taking it that way. So now that we know that, let me give you some guidelines to reduce or to solve block diagrams. The only thing you have to do is to move the takeoff points and the summing points. There are some signals here. Well, there are some signals. I don't know. For example, this. So you start switching them, and if you have blocks between them, you try to rearrange things so that you end up either with parallel blocks that you can replace by this, or you end up with a feedback loop. And then you can replace it with this block here. So you perform operations, you move summing points and takeoff points until you find either this or this, and then you replace the whole thing by a new block and keep on doing operations. But remember, if you find this situation, there is no way you can switch these places. At the most, you can go the other way. You can start moving this to the other side or this to the other side, but there's no way you can switch these two by a direct operation. So let me solve a quick example to illustrate all this. Here is the situation. We have this block diagram with one feed forward path and two feedback loops. We're trying to find feedback loops and parallel paths. We cannot switch these two things here. We cannot switch these two things. So maybe what we should do is try to move this summing point here. Okay, we need to do that. But if we put the summing point here instead of here, then the overall output of the subsystem, what we get at this point, changes unless we multiply this by 1 over G2 to counteract the fact that this signal is going to be multiplied by G2 later on. So let me redraw this nicely. There it goes. I've joined the two transfer functions here. Well, now we can apply here the commutativity of these 2 points. We can switch them. Again, let me do it. Here it is. And now we find here a feedback loop, and we know that it can be replaced by G2 over 1 minus, because there's no minus sign here, 1 minus G2 2 times 1, because there's no transfer function here, or there is 1, which is just that, 1. So if we redraw the whole thing, we get this. This is what we get. Now, if we try to, again, here we cannot switch things, but if we move this point here, we would be stuck, because again we would find a situation in which we cannot switch things. So the only operation applicable here is to move this here, or maybe move this there, which is the same. So let me do it. If we move this summing point here and get rid of all this, in order to get the same output here, we must multiply here by G1. So let me do it clean, in a clean way. There it goes. And finally, if we switch these two, we will find a parallel structure here and a feedback structure here. So let me write or draw this final block diagram. There it goes. This part here is equal to G1 plus G3 over G2, and this is in series with this feedback loop. I think I forgot to put here the minus sign. So this is equal to G2 over 1 minus G2 over 1 plus the direct loop G2 over 1 minus G2 times G1 times G4. And if you multiply numerator and denominator by 1 minus G2, we get G2 over 1 minus G2 plus G1 G2 G4. This is the other part of the overall system. And if you put both functions in series, the overall solution with our y here and our I don't know, r here, I don't know what sign I used, well, there's no origin, okay, let's call it r, would be G1 plus G3 over G2 times G2 over 1 minus G2 plus G1 G2 G4. Okay, I hope this is enough to show you how to actually, that wasn't that easy, but hopefully you've made sense of it, and now you're capable of solving block diagrams on your own.